Hello everyone. This is Dr. Keswani. Welcome in the second lecture of Software Engineering Fundamentals. In this lecture, we will discuss about uh, the historical. We will continue the historical evolution of software engineering uh, that we have elaborated in some part is elaborated in the previous lecture, and let us discuss the rest of the things. Uh, the content of this lecture is uh, consisting principles of software engineering. Some major principles and some additional principles are there. Then we will discuss about elements of software engineering. Then what are the aspects of software engineering, software products and its types, essential characteristics of well-engineered software product, and software product engineering. What is the meaning of software product engineering? Then software process and its characteristics will be discussed in this lecture. Software engineering engineer and his skills will be discussed in this lecture. Then we will discuss about the emergence of effective software engineering, and lastly, we will establish the relationship of software engineering to other areas of the engineering. So, come to the first part, that is principles of software engineering. So, principles of software engineering are the rules to abide the software development community, and that's why we can say it as a principles. Okay, so in software engineering, principles are evaluated based on observations of thousands of projects, and they collected wisdom people thoughts and wisdom of the people who have learned through software development experiences. So principles of software engineering basically based on the observations, based on the wisdom, based on the concepts used in the previous projects of the software development. Maybe some major projects or maybe some minor projects. Okay, so let's come to the major principles of software engineering. So these major principles of software engineering suggested by Davis in 1994, and he suggested most important 15 principles that he called as major principles of software engineering. The first principle is make quality number on priority. Second is high quality software is possible. You can you can uh, you can establish that thing, that high quality software is possible. Development of high quality software is possible. Give products to customers early is the third principle, major principle. Determine the problem before writing requirements is the fourth principle. The fifth principle is evaluate design alternatives. If you have several designing options, so you have to evaluate, you have to choose the appropriate design alternative among the all available alternatives. Then use an appropriate process model. There are so many models for development of software, like V model is there, RAD model is there, spiral model is there, uh, iterative enhancement model is there, waterfall model is there. So there are several models available, but you have to use an appropriate process model is the sixth principle. Seventh principle, use different languages for different phases. Eighth principle, minimize intellectual distance. If there are some bridges, if there are some egos in the development team, then it will produce uh, hurdle in the development. So minimize intellectual distance to find out the maximum, to achieve the maximum productivity through the software project. Okay. The ninth principle is put technique before tools, and the tenth principle is get it right before you make it faster. 11th principle is inspect code. If you inspect your code, although being a developer, your your view, your thought about your product is biased, no doubt, because every developer think that his developed project is very much uh, effective and quality product, but always it is not so. So inspect your code. Then the 12th principle is good management is more important than good technology. So uh, management means management have two important activities: monitoring and control. So good management is more important than good technology. Adoption of good technology is the 12th principle, which is very important. 13th principle, major principle, is people are the key to success. Associate all the peoples, associate all the relevant people, convince them, associate them. Okay. They will work for your success, they will work for your project, and make it success. Then the 14th is follow with care. You have to follow each and every module. You have to follow each and every concept of software engineering in a religious manner. Then last last major point is, that is 15th point is, 15th principle is take responsibility. You should take the responsibility, the entire responsibility. uh, 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 Work like, you should work like a leader, not like a worker. Okay. So take responsibility, assign the responsibility to the staff members, and take the responsibility of failure as well as the success. Okay. So all these are all 15 uh, principles, which is elaborated by the Davis in 1994. Let us more discuss about all the uh, principles one by one. The first principle is make quality number one priority. So, the first requirement must be quality. A customer will not tolerate a poor quality product, regardless of how you define quality. So, quality must be quantify, and mechanisms put into place to motivate and reward its achievements. So make quality number one priority is the first principle, major principle. The second major principle is high quality software is possible. So high quality software is always possible, and all techniques to enhance quality considerable should be adopted. Okay, so these require techniques involve customers, the customer, the prototyping and simplifying design, conducting inspections, and hiring the best people. So you can achieve high quality software through the uh, understand the need of the customer, to simplify the design of the product, to inspect through inspections, and finally to hiring the best people for your product. Okay, so this is the second principle, major principle. The third principle is give products to customers early. Yes, it is true. The most effective way to ascertain the real customer need is to give users a product and let them play with it. So if you provide your user a dummy of his project, so you can, and uh, you can give him a freedom to play with it, he will give you a real feedback. So better is to deliver a quick and dirty prototype early in development, rather gather feedback, write a requirements specification, and then proceed with full scale development. If you are not doing so, you will not make a quality product or a customer acceptable product. Okay. So the third principle is give products to customers early, not give at the final stage. Because at the final stage, if some changes are requested by the uh, customer, you cannot uh, provide the desired solution to the customer. Okay. Next, fourth is determine the problem before writing the requirements. So most engineers rush to offer a solution for the problem given without understanding the problem clearly. If the engineer's perception of the problem is accurate, only then the solution may work. Further, before you try to solve a problem, be sure to explore all the alternatives and don't be blinded by the obvious solution. Don't accept, don't adopt obvious solution. Always explore the alternatives. Always try to get the best solution to the requirements. Okay. Next, the fifth major uh, principle is evaluate design alternatives. After the requirements are agreed upon, you must examine a variety of architectures and algorithms. You certainly do not want to use an architecture simply because it was used in the requirements specification. After all, the architectures was selected to optimize the understandability of the system's external behavior. So the architecture you want is the one that optimize conformance with the requirements. So evaluate design alternatives is the fifth major principle of the software engineering. Then the sixth principle, according to the sixth principle, use an appropriate process model. Means what? There are dozens of process models. I earlier told you that waterfall life cycle, prototyping, incremental approach, spiral model, operational prototyping, RAD model, rapid application development model, and many other models are there. When there are several models, how to uh, choose. So selection of a appropriate process model is an important thing. So there is a no such thing as a process model that works for every project. Each model is each project wants a different model. You cannot treat, you cannot adopt one single model to develop multiple projects. Okay, so each project must select a process that makes the most sense for the that project on the basis of corporate culture, on the basis of willingness to take risks, or application areas, or uh, you can say the uh, volume volume of the requirements. Okay, so uh, uh, according to the sixth major principle, you should use an appropriate process model. Then, according to the seventh major principle, use different languages for different phases. Our industry's eternal thrust for simple solution to complex problem has driven many to declare that the best development method is one that uses the same notation throughout the life cycle. So this is not the practice in any other engineering discipline. Select a set of technique and language that is the best for the phase you are working in. So use different language for different phases. The transitions between phases are difficult, but using the same language doesn't help. On the other hand, if a language is optimal for certain aspects of two phases, by all means use it. So, according to the seventh major principle of software engineering, use different languages for different phases. As per the eighth principle, that is minimize intellectual distance. As I said earlier, that intellectual distance as the distance between the real world problem and the computerized solution to the problem. So it is suggested that you can make uh, problem uh, you can make simplify the problem through reducing the intellectual distance, through minimizing the intellectual distance, okay, through your designing. It is possible. It will happen only. It is possible. It will possible only through the best adoption of best designing practices. The next and ninth principle is put technique before tools. Yes, an undisciplined carpenter with a power tool becomes a dangerous undisciplined carpenter. Okay, so and likewise, an undisciplined software engineer with a tool becomes a dangerous undisciplined software engineer. Before you use a tool, you should understand and be able to follow and appropriate software techniques. There are various software tools and techniques available, but you should understand which type of tool, which kind of technology you should adapt for your software project. So, if you need some tool, if you need some help, use appropriate tool, appropriate technique. Okay. Then the according to the third principle, get it right before you make it faster. It is a far easier to make a working program run faster than to make a fast program work. Don't worry about optimization during initial coding. Every software project has taught schedule procedures. So, if you have some pressure, if you have some management pressure, get it right before you make it faster. Given this situation, any type of component is produced on time and it works reliably, there is cause for celebration. Try to be the reason for celebration rather than depression. And if your program works, everyone on your team will be appreciated. So get it right before you make it faster. Is the 10th principle of software engineering. The 11th principle of software engineering is major principle is to inspect code. So I had elaborated this point earlier also. Project schedule should account for time to inspect and correct every component. Inspecting the detailed design and code firstly proposed by Michael in 1976 is a much better way to find errors than testing. Inspect code is much better way to find errors than testing, because testing, there are several types of testings and testing will consume your uh, most of the time of development. So inspect your code. Inspection can find as many as 82% of all errors, cons- consumes about 15% of the development resources, and reduces net development cost by 25 to 30%. Okay, so inspect your code. It is the 11th principle. The next principle, 12th principle, is good management is more important than good technology. So the best technology will not compensate for poor management. And a good manager can produce great results even with inadequate resources. So, good management motivates people to do their best, but there are no universal right style of management. So, management styles must be adapted to the situation. Good management is more important than good adoption of good technology. Remember this thing. So this is the 12th principle of major principle of software engineering. According to the 13th major principle, that says that people are the key to success. Yes, highly skilled people with appropriate experience, talent, and the training are the key to success. Yes, it is very much right, because the right people will, with insufficient tools, language, and process will succeed. The wrong people with appropriate tools, language, and process will probably fail. When interviewing prospective employees, remember that there is no substitute for quality. So, appoint only quality people. Appoint people uh, who are delivering quality product, who are developing quality product. Okay, quality product comes through the adoption of quality practices. As per the 14th major principle, that is follow with care. Just because everybody is doing something does not make it right for you. It may be right, but you must carefully assess its applicability to your environment. Okay, so object orientation, measurements, reusable process improvements, computer-aided software engineering tools, prototyping, all these might increase quality, decrease cost, and increase user satisfaction. So follow with care. And lastly, the last major uh, principle of software engineering is to take responsibility. If you develop a system, it is your responsibility to do it right. Take that responsibility. Do it right, or don't do it at all. When a bridge collapses, we ask, what did the engineer do wrong? Okay? When software fails, we rarely ask this. When we do, the response is, I was just following the 15 steps of this method, or my manager made me do it, or the schedule left insufficient time to do right. The fact is that in any engineering discipline, the best method can be used to produce terrible design, and the most method, inadequate method to produce the quality design. Okay, so these are major principles of software engineering, and some additional principles are also there apart from these 15 major principles. The first principle is understand the customer's priorities. It is possible that customers would tolerate 90% of functionality delivered late if they could just have 10% of it on time. Find out. Okay, so uh, there are some additional principles, like understanding the customer's priority. Second is, the more they see, the more they need. The more functionality or performance you provide a user, the more functionality or performance the user wants. So this is the second principle. Third principle, plan to throw one away. One of the most important critical success factors is whether or not a product is entirely new. Such brand new applications or architectures or interfaces or algorithms rarely work for the first time. So the third principle is plan to throw one away. The fourth principle is design for change. The architectures, the components, the specification techniques you use must accommodate must accommodate the major changes. So, a design for change is the fourth additional principle. Design without documentation is not design. It is very important. If you, yeah, once a software engineer say, I have finished the design. All that's left in its documentation. Can you imagine a building architect saying, I have completed the design of your new home? All that's left is to draw a picture of it. So, design without documentation is not a design. We should always make a documentary evidence for design. The next one is use tools but be realistic. Software tools makes their users more efficient. By all means, use them. Just as a word processor is essential to a writer, a case tool is essential to a software engineer. Okay, so like if you are a writer, you need a word processor. Likewise, if you are a software engineer, you should need you have a need of case tools. So according to the seventh principle, don't use shortcuts. Avoid tricks. Many programmers love to create programs with tricks. Construct that platform or functional correctly, but in an uh, insec- uh, if you are making your software in an insecure way, is a very or you are using the tricky code, then it is very harmful for the quality of the software. So you avoid tricks, avoid unrealistic things, avoid tricky codes. Okay. The next additional principle is encapsulate. Information hiding. Encapsulation means information hiding. So information hiding is a simple proven concept that result in software that is easier to test and much easier to maintain. So encapsulate it. The next is use coupling and cohesion. The coupling and cohesion are the best way to measure software's inherent maintainability and adaptability. So I will learn you, I will taught you what is coupling and what is cohesion in next lectures. So it is a principle as per the additional ninth principle of software engineering, which says use coupling and cohesion in an appropriate manner to reduce the complexity in your design. Okay, so these are uh, some additional principles which are suggested by uh, many scientists time to time. And the last additional principle is expect excellence. So it is suggested to work for excellence. Your employees will do much better if you have high expectation for them. So you should work for excellence. You should code for excellence. Okay. So this is all about principles of software engineering. There are 15 major principles and some additional principles are there. I have elaborated all the principles. Hope you have and you have understand all the principles of software engineering. Now come to the next part, that is elements of software engineering. So there are some elements, important elements of software engineering, like methods, procedures, uh, tools and techniques. So methods, how you uh, how you define a method. A method is a procedure, you can say, a procedure for producing some result is called a method. It is also referred to as a technique. Methods generally involve uh, some formal notation and processes. So method is a procedure to producing some results. And what is procedure? A procedure then combines tools or methods to produce a particular product, sorry, particular product. So a procedure, you can say a procedure is a combination of tools and methods to produce a particular product. So algorithms are examples of procedures. Okay. Now the tools. Tools are automated systems that increase the accuracy. You can say tools are the automated system which are helpful to increase the accuracy, which are helpful to increase the efficiency, productivity, and increase the quality of the end product. So, what is end product? End product it is a software system. So, tools are some automated systems which are responsible to increase the accuracy, efficiency, productivity, and quality of your software system. A tool that automates the preparation of a data flow diagram can increase the accuracy, efficiency, and productivity. So, design through through the appropriate tool, you can prepare the data flow diagrams or flow charting, and to increase the understability, to increase the accuracy, okay, and to increase the productivity. One thing is also important: idea. Idea means philosophy. Philosophy for building software systems. Approaches are important. Philosophies are important, like object oriented uh, designing, object oriented concepts are approaches are philosophies are very much important when you are building a software. So different approaches having their pros and cons, and they are and make them suitable for they are vary from your from project to project. You should adopt most suitable approach for your project, because it is depends on the environment, related environment. Okay. The next thing is aspects of software engineering. What are the aspects of software engineering? From software system development point of view, software designer can also be viewed in terms of certain aspects. And in this direction, some scientists in 1990 outlined seven aspects of software engineering. Like, first aspect is uh, system specification. Second is writing large programs. uh, Third is to prepare documentation. And fourth is testing and integrating code is aspect of software engineering. And then creating maintainable code is the next aspect of software engineering. And the sixth aspect is using tools. And last aspect is quality assurance. So these are aspects which are suggested to which aspects of software engineering. uh, I am repeating again. The first aspect is system specification. To make system specification, to understand system specification. Then writing large programs, because software engineering came in existence as a solution of complexity of large programs. So writing large programs. Then Devel- development of documentation. Documentation is an important part, important thing which is related to the quality of the system, which is related to the maintainability. Documentation will enhance the maintainability of the system. And testing and integrating code. Testing. Testing means through testing we can ensure the quality of the system. So integration means we are reducing the bug and errors in the system through the integration, proper integration. Then creating maintainable code means what? A code which is easy to maintain. Using tools. Using tools means there are several tools. I earlier said that there are several tools, and they are automated systems. Basically, they are increasing used to increase the accuracy, efficiency, productivity, and quality of the end product. So, using appropriate tool, you can make your program readable. You can enhance the quality of your software. And last aspect is quality assurance. Means you have to ensure the quality of your software system through uh, using various tools and techniques. Okay, so this is all about today's class. Uh, we will discuss in the next lecture about software project and its types, and these all are the areas we will discuss in the next class. Uh, these are the these are some reference books. You can, for more information, you can consult with these books. All concept related to the software engineering are demonstrated properly and elaborated properly in all these books. So you can, if you are having some doubt related to any concept which I elaborated, which I discussed in this lecture, you can ask, you can consult from these reference books. Okay, now I'm closing this session, and this is all from my side. Thank you.